Hi everyone, welcome to our final video on cubic functions. We are looking at the last little bit here, which is a couple of extra transformations to this original graph of y equals x cubed, our original type of cubic graph. And as the title of the video suggests, this will be the transformations known as translations, which, as we've defined previously, these include a horizontal or a vertical shift. Now, for this initial example, we're going to go through this slowly, and once we refresh our memories on what these translations mean, how the graph tells us which way this is being shifted, we'll go through the next two questions a little bit quicker. So first of all, for this one, we have our original function. Let's do that in color here. So we have this is our original cubic, our y equals x cubed, that's what we're used to. And then we have this next bit here, and that is our transformation. So we want to see what this actually means. So just for this one example, we're going to do a table of values again. So x, y, and I'm going to sketch in a couple of values here: -2, -1, 0, 1, and 2. Okay, so here I'm going to substitute in all of these values and then just have a look at what that's going to give us. Now, subbing in -2 into here, that gives me -2 cubed, which is -8, minus 8, that gives me -16. Here we have -1 in place for the x, that gives us -1 cubed, which is -1, minus 8, which is -9. And substituting in 0 gives us 0 cubed, that's 0, and then minusing 8 from 0 gives me -8. And just filling in the rest of these a little bit quicker, I get these values here. Now you can pause the video and check these for yourselves, substituting these in, but we're going to look at what something like this is going to roughly look like. So if we sketch this in, I have my y-axis, my x-axis. So let's just put in these values, see what our cubic ends up looking like, and this will give us a bit of a recap on what our translations mean. Okay, so when x is -2, we're down to like -16 here. So that's our first point. When x is -1, we get -9. That's about here. And when x is 0, y is -8. Let's draw that in here. When x is 1, y is -7. That gives us something around here. And then when x is 0, when x is 2, y equals 0. So that's going to be this thing here. Okay, so if I go ahead and sketch this, I can see that connecting these dots once again gives me a cubic. But what's different about this cubic? Well, we can see normally our y equals x cubed one would look something like this. So what's actually happened? We've shifted down. So the point of inflection, actually, this point where we momentarily stop and then continue up in the same direction, our point of inflection here is at the coordinate 0, -8. So it's gone from where it typically would be at the origin of 0, 0, it's gone down 8 units. Now, here we have shifted each part of this graph down by 8 units. And that's given to us by the part of the equation, part of the function's equation, which is the transformation. So remember, when we have a positive or a negative number at the end here, that gives me a vertical translation. So this shifts it either up or down. When this sign is negative, it's going to shift down. When the sign is positive, it's going to shift it up. But we can confirm this using our table of values. So here we can clearly see that the point of inflection has moved, and the entire graph itself has actually moved down. Now we can also do this by finding some key points. So we can always find the point of inflection by seeing where it goes from 0, 0 based on the transformation that's included in our original equation. And we can also find some other key points, so y-intercepts and x-intercepts. So I've already drawn this here, and our table of value tells us these anyway, but let's just confirm what these intercepts are. So we get our y-intercept when x equals to 0. So substituting in x equals to 0 into my equation here, we get y equals 0 cubed minus 8, which is negative 8. And cool, that makes sense. It cuts my y-axis at negative 8 in the y. So that's good. We've confirmed that. Let's check the x-intercept. We get that when y equals to 0. So that means that 0 is going to equal to x cubed. That's shocking. Let's draw that again. X cubed minus 8. Okay, now this becomes a cubic equation that we can solve. Remember, we've done these before. We want to isolate the x on its own. So first I want to get the x cubed by itself. So I'm going to add 8 to both sides. So that's going to give me 8 over here equals to x cubed. And with our cubic equations, if you remember, once we get to this stage, we can always undo the x cubed by taking the cubed root of both sides. Now, taking the cubed root of 8 gives me 2. You can confirm this on your calculators. And my x value is 2. And that makes sense because look at where we're intercepting our x-axis. That is at the value of 2. So this is how we can start to sketch these cubic functions with different types of transformations. Now in this video, we're looking mainly at these translations, these horizontal and vertical shifts. Okay, let's look at another question. Y equals to x minus 1 all cubed. Now you can see here that my transformation is working on my x now instead of my y. Now we're just going to draw another table of values just to double check that what we think might be happening, which is some kind of horizontal shift, we're just going to confirm that really quickly with this table of values. Now, if you don't want to do the table of values, if you want to just try immediately and to find your intercepts and recall what you know about these type of translations, you can do that. But I'm just going to run through this a little slower just so we are all on the same page. So I'm going to go once again from -2 all the way up to +2. Okay, let's substitute some values in here. So substituting in -2 for x, this gives us -2 minus 1, which is -3. All cubed, if I cubed -3, that gives me -27. Now, here, if I substitute in -1, that gives me -1 minus 1, that gives me -2. Cubed gives me -8. If I substitute in 0, I get 0 minus 1, it's -1, or cubed gives me -1. Substituting in 1 here, this gives me 1 minus 1, that gives me 0. Cubing 0 just gives me 0. And here I have, substituting in 2, I get 2 minus 1 is 1, cube that gives me 1. Okay, let's have a little sketch of this, because we can already see, hopefully here, that alarm bells are sort of ringing. We have something different to what we had in previous examples, in that I have, when x is 0 here, my y is -1. And I get this 0 in the y reappearing when x equals to 1. So that's going to tell us something pretty important here. But let's just draw this out, see what happens first. So I'm not going to make this too fancy. I'm trying to do this quickly for the sake of time. So when x is -2, y is -27. So that's like way down here. When x is -1, y is -8. It's about here. When x is 0, y is -1. When x is 1, y is 0. It's here. And when x is 1, y equals to, sorry, when x is 2, y equals to 1. So that's about there. Okay, so let's look at what's going on here. Let's make this even lower just to make it nice and obvious. And now I can sort of see here, as I draw this up, my point of inflection ends up right here. So we can see that this point and this point sit roughly, in terms of kind of symmetry wise and how they look with the function, they sit similarly to these 2 points in this one. So they sit on either side of the point of inflection, and we can kind of see that for these two values, see, we have -1 and we have +1 here. So those two are on either side of the point of inflection. Everything on this end, that's where it just starts shooting down, 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 down. And everything over on this end greater than x equals 2, that's going to be the point up here, where it's just going to keep shooting up. So we can see that this cubic looks like it's kind of been shifted from the origin over 1 unit to the right, because now its point of inflection is the coordinate of 1 in x and then 0 in y. So in essence, I have made here a horizontal shift. And if we remember from when we did this for parabolas initially and some of our other functions, this thing here is a horizontal translation because the number is acting on the x. And we talked about before that if this is negative, the thing gets shifted in the opposite direction. So since this is negative, it's getting shifted 1 unit to the right. And everything here, compared to our original cubic, everything gets shifted 1 unit to the right. Now, if this sign in front of the 1 was positive, it's going to get shifted to the left. When we have these x's here, we're looking at the opposite direction. So this negative here means a shift 1 unit to the right. Okay, so we have now covered 2 of those main transformations. horizontal translations and vertical translations. Let's bring this all together to look at one final example, which is this one down here. So we have now multiple transformations we're dealing with. We have this negative here from a video or so ago. We said that this ended up being a reflection. So the negative sign in front of the cubic, the x cubed, that means that it's going to get flipped. Remember, we had this reflection thing around the x-axis. This guy here, this is something that makes the graph, it changes the scale of the graph. It makes it either narrower or wider as well. So it affects the growth with which the y shoots up. This thing is called a dilation. And finally, the effect of adding this number at the end here, this becomes our translation. And since it's not inside a bracket with x, since it's outside, it's acting on the y. So this is going to be a vertical translation. It's going to shift it up or down. So let's just look at how this would roughly look like. And we're going to try to sketch this particular thing here. So let's first look at what happens to the point of inflection. So it's not moving left or right. So the original one, if this was y equals x cubed, this would be at the origin. Now, since there's no horizontal translation, the x value is still going to be 0. But here, because we're adding 6, that means we are going, everything is getting shifted up 6 units. So everything, including our point of inflection, goes up 6 units. So here, it's going to go from 0, 0 to 0, 6. Because this is vertical, it's acting on the y coordinate here. So the y coordinate is increasing from 0 up to 6. Now, this is going to be a reflected cubic. So instead of looking like this, it's going to get flipped. It's going to get reflected. So it's going to look like this. And we're going to sketch that in just a minute as well. But it's going to look like this red one, but it's getting shifted up 6 units. So it's going from the origin 0, 0, the point of inflection, to 0, 6. So this thing is actually going up here. It's going to look something like this. Now, we know what the point of inflection is. We also know what the y-intercept is, because the y-intercept is where it crosses the y-axis when x equals 0. So we've already found a coordinate here. We're going to clarify that anyway. Now, we've drawn this. We've shown that it's been shifted up 6 units. We've shown that it has been reflected, and now we just have to put in a point of scale or an x-intercept as well, just to give us an idea of the effect of this dilation, this guy here, on the values of the graph. So remember, with this exercise, all we're doing is sketching these and labeling the point of inflection and the axes intercepts. So that's all I want us to get out of this particular video. So we've identified all the transformations, we've started to draw this. Now we just want to find some of these key points. Now we found the point of inflection over here. Of 0, 6. We just want to find the y-intercept and the x-intercepts. Now, we've already found the y-intercept, but let's just double check that this works. I'm going to substitute in x equals 0 for the y-intercept. So that's going to give me y equals minus 2 times 0 cubed plus 6. Okay, minus 2 times 0 cubed is like saying minus 2 times 0. That gives me 0, plus 6 gives me 6. Okay, sweet. So I found my y-intercept, and I can confirm that by saying, okay, my point of inflection here is actually my y-intercept as well. Now we want to find the x-intercept. And we get the x-intercept when y equals to 0. So that gives me 0 equals minus 2 x cubed plus 6. And I want to solve this cubic equation in order to find x. So this is where the skills we got a couple of videos ago start to translate over to curve sketching. So here we want to solve this equation. So we want to strip away everything until we're left with x here. So the first thing we're going to do is we're going to subtract 6 from both sides. That's the last thing that was done to the x. So doing this, I get minus 6 equals to minus 2x cubed. Okay, now I want to get to the x cubed first before I get to the x. So I want to undo this multiplying of negative 2 by dividing through by negative 2. That'll give me a coefficient of 1 in front of x cubed, which just gives me x cubed. So I'm dividing both of these through. Minus 6 divided by minus 2 gives me positive 3 equals x cubed. And now, once I get to this stage, remember this is always the second last step we get to when we solve cubic equations. We want to undo this cubing of x by taking the cubed root of it. And we're going to do this to both sides. So on the right hand side, I'm left with x. On the left hand side, this is going to be an irrational number, so I'm just going to leave this as the cubed root of 3. And this cubed root of 3 is my x-intercept, because I'm finding a value of x when y equals to 0. That's always going to be my x-intercept, in the same way that the y-intercept is always given to us when x equals to 0. But that brings us to the end of this video on curve sketching with some new transformations. Thank you so much for joining me, and I'll see you next time.